Alright, so in this video we go over section 8.3, the law of cosines. So this is the law that we are going to use to solve triangles that are side angle side and all sides. Alright, so and again, here's a review of what we did in the previous section, in which we recall all the 4 cases. So this time around we're going to look at cases 3 and 4, in which 2 sides and the angle in between those 2 sides are given, and the 3 sides. Alright, so the formulas for law of cosines, here's the 3 formulas. I mean, you don't have to memorize if you don't want to, that's fine. But rather than just solving the problems, I'm gonna prove this formula. Well, I'm going to prove only one case, of course, not the 3 cases form. So when we look at one of the cases, you can pretty much repeat the process to deduce the other 3. So I'm going to deduce the third one actually. So we're gonna have this triangle. Notice it's not a right triangle, and one of the vertices is at the origin, another vertex is the point xy, and another vertex is the point c comma 0, where, well, x equals some c, distance c, and notice there's no change in the y direction, so that's why this is 0. Alright, if we use trigonometry to relate the sides, in this case, well, I'm gonna cut this triangle into 2 right triangles, just the same way we did it in the previous section for the law of sines. All right, but in this case, if we are to prove a law of cosines, I'm not gonna do sines. I'm gonna do cosines. All right. So let me locate the angle A. So cosine of angle A will be adjacent over hypotenuse, which is x over b, and cosine, or actually I need sine in this case, not cosine. I'm going to put this together. So sine of angle A is y over b. All right. So in this case, well, from here, that's actually going to be familiar from previous chapters. You know that the x coordinates represent the b cosine angle, or theta, r cos theta. Well, and y equals r, or rather b sine the angle. But in this case, we're, instead of using r and theta, we're looking at a's, b's, and c's. All right. So the point right here, this is going to be b cosine of a and b sine of a. Again, recall that the points in the circular radius are of the form cosine comma sine. Even though, again, we're not looking at circles, we're not looking at thetas and radii. Well, but I mean, the same idea is going to be coming into play here. All right, our main goal is to find the length of the side A. Of course, this side A is not part of the right triangle. Otherwise, I would have used the law of sines or simply the Pythagorean theorem, but it's not the case. So this distance A, to find this distance A, I'm going to use the distance formula. So the distance formula, you might want to recall, d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, but adapted to our letters, well, our d is going to be the letter A. Well, let me actually, yeah, that's fine. It's going to be the letter, okay, let me write it down here. A equals the square root of, in this case, x2 minus x1, so that's the distance from here to here, x2, x1, That's x minus c squared plus y2 minus y1 y minus 0 squared. Alright? And then from here, well, you might want to square both sides to get a squared equals to, in this case, x minus c squared, but I'm going to substitute x with this x right here with b cosine a. And this y minus 0, that's simply y squared, but y is b sine of a, quantity squared. Notice I didn't write this 0 anymore. And in this case, well, actually, I needed to write a c over here. Just give me 1 second here. So minus. So in this case, when I FOIL this part, I'm going to have a binomial squared, a squared, equals b squared cosine squared a plus 2 times b, or actually minus, because there is a minus here, minus 2bc cosine a, and then plus c squared. Alright? And then over here, b squared plus b squared sine squared a. Alright? Let me keep going over here on that side. So all we're going to do now is simply rearrange terms, and because something that is going to be worth to observe here is that these two terms right here, let me show you, I'm going to put these two together for one reason. Number one, this one and that one. I'm not really combining anything yet, just this is squared again. So this is b squared cosine, actually, well, cosine squared a plus b squared sine squared a minus 2bc cosine a. So a squared equals to, notice the common factor b squared times cosine squared plus sine squared, or simply sine squared plus cosine squared. And you might remember this as an identity. This is equal to 1. Alright? So a squared equals, oh, I forgot another plus c squared. Okay, this plus c squared, I forgot to put it, c squared plus c squared. Okay, I'm just gonna put it in the end. So I'm gonna end up with b squared times 1 plus c squared minus 2bc cosine a. And that's exactly the formula right here. Right, that's what we wanted to show. And of course, you can do the same process by just interchanging the labels, and you will end up with this formula. All right, let's apply the law of cosines to a couple of examples. So let's solve SAS triangle. So solve the triangle a equals to 2, b equals to 3, c, which is unknown. And then in this case, well, angle A is unknown, angle B is unknown, and angle C is given as 60 degrees. Alright, so in this case, I cannot put together A with B to use the law of sines because I don't know any of the angles. And I cannot put together B and C and use the law of sines because I'm only given one piece of information each. So how are we going to do this? Well, so in this case, I'm going to look for the, I'm going to use law of cosines to find the side C. So for the side C, c squared equals, I'm going to use the formula, the first formula, c squared equals a squared plus b squared. It looks a little bit like the Pythagorean theorem, but minus 2ab cosine c. A squared plus b squared minus 2ab cosine of c. So c squared, which is c squared, a squared, which is 2 squared, plus b squared, 3 squared, minus 2 times 3, cosine of c, which is 60 degrees. Okay. So let's go ahead and simplify this. So that's going to be 4 plus 9, that's a 13. Minus 2 times 2, which is 4 times 3, that's 12. Times cosine of 60 degrees is 1/2, or cosine of pi over 3. That's 1/2, and that's c squared equals 13 minus 12 over 2, 12 minus 13 minus 6, which is 7, and then c equals the square root of 7. In this case, we're not going to use plus minus notation from the square root property because we're talking about sides of a triangle, and those are meant to be positive. All right, so we have the side. So we have one of the sides. All right, so now what are we going to do? Well, there is that we have a few alternatives here. So in this case, we could use actually the law of sines here, or we can use the law of cosines. It's up to you. But I mean, since we are practicing with the law of cosines, let's use the law of cosines to relate side. Actually, I'm gonna find the angle A using side A and side B with angle C. How is that gonna work? Well, let me write that down. A squared equals B squared plus C squared minus 2BC cosine A. All right. So in this case, what are we going to do? So let me solve for cosine A. So first of all, in this case, negative 2BC cosine A equals A squared minus B squared minus C squared. And then I'm going to divide both sides by negative 2BC to get cosine of A to be equals to, well, in this case, since I'm dividing by a negative 2BC, I'm going to change the sign of everything here to B squared plus C squared minus A squared. And in this case, cosine of A is going to be B squared, which is 3 squared, plus C squared, which is the square root of 2, actually 7, not 2. And then minus A squared, which is 2 squared, divided by 2 times B, which is 3, times C, which is root of 7. So that's going to be cosine of A equals, in this case, I'm going to have a very weird quantity here. So that's going to be 9 plus 7. That's a 16. 16 minus 4. That's going to be 12 over 2 times 3, root of 7. That's going to be 6 root of 7 in the denominator. So in this case, when we do arc cosine or the inverse cosine, well, this reduces to, I'm not going to rationalize in this case the same way we would do, you know, in other situations, right? Like but because in this case all I want is the angle. So 12 over 6, that's 2 over root of 7. So that means A equals cosine inverse of 2 over root of 7. All right. So A, in this case, the angle would be roughly 40.9 degrees. Actually, let's verify that. So second cosine to give us cosine inverse of 2 over root of 7. 40.9 indeed. So now we have another angle, 40.9 degrees. And in this case, we don't have to use any other law of sines or cosine, because we can simply do, 180, right? 180 minus 40.9 minus 60, and that's 79.1 degrees, and we have that triangle solved. Let's do another example and call it a day for this section. Well, so solve the triangle A equals 4, B equals, that's actually an A, not a 9, B equals 3, C equals 6. In this case, notice we're not given any of the angles. No, we're not. A equals, B equals, C equals. Nothing. We're not giving anything. So we're gonna use the law of cosines to find cosine of A. Well, which one are we gonna use in this case? Well, we're gonna use it twice because, well, we know the three sides. We know the three sides. So knowing the three sides, we can use the third one to find the angle A, and then the second one to find the angle C. So I'm gonna start with the third one. A squared equals B squared plus C squared minus 2BC cosine of A. Very similar to what we did in the previous example when we solved for cosine of A. Actually, to avoid too much of work, I'm just gonna use the result from the previous part. Okay, so from here, so cosine of A equals B squared plus C squared minus A squared over 2BC. And cosine of A equals, okay, B squared, C squared, A squared, so that's 3 squared plus 6 squared minus 4 squared over 2 times 3 times C, which is 6. So cosine, that's a 9 plus 36 minus 16 over 2 times 3, which is 6 times 6 equals to 36. So cosine of A equals, in this case, if we add this all up, that's 29 over 36, and we need A equals cosine inverse of 29.36, which in this case, well, let's see, we can second cosine inverse of 29 over 36, and that's 36.3 degrees. So that's the angle A. So finally we have an angle 36.3 degrees. And then from here, well, let's see. So B, how are we gonna get B? So we need to use the formula of the law of cosines that involves the angle B. That is B squared equals A squared plus C squared minus 2AC cosine of B. So let's see, I'm gonna move this whole term that is negative over here, 2AC cosine B plus b squared equals a squared plus c squared. That way everything remains positive. It's easier to work like that. And then I'm going to move this b squared to the right hand side with the opposite sign to ac cosine b equals a squared plus c squared minus b squared. And then cosine b, okay, divide both sides by 2ac to get cosine b by itself. B equals cosine inverse, oh, well, not yet. Cosine B, let's not do cosine inverse yet. Let's put numbers first. So a squared, which is 4 squared, plus c squared, which is 6 squared, minus b squared, which is 3 squared, and 2 times a times c, which is 6, and then this is actually going to be cosine b. That's simplifying this. This is going to be 16 plus 36 minus 9 over 6 times 4, 24 times 2, that's 48. Combining this together, cosine of b will be 16 plus 36, that's 40, 52, minus 9, 52 minus 9, that's 43. All right. And divide that by 48. And angle B will be cosine inverse of 43 over 48. And let's do this in the calculator. And that's 43 over 48. And that's 26.4 basically. Alright, so to find angle C, we don't have to do all these law of cosines anymore. Because recall that the sum of the angles has to be 180 degrees. So just from 180 degrees subtract these two. So 180 minus 36.3 minus 26.4. And that's 117.3 degrees. And we have that triangle solved. And that's about it for this section. I'll see you in the next video.